Intermediate Session 1. It's going to be on algebra. Before you continue watching this video, make sure to subscribe and like. The topics we're going to be covering today are what is algebra, variables and equations, linear equations, and system equations. The first topic we're going to cover today is what is algebra. Algebra is a branch of mathematics that substitutes numbers with variables, which are basically letters. We can use any letter of the alphabet, but we mainly don't use E, I, well, basically that's it. We mainly don't use these because they have other significant values. An equation is like a scale. What you do to one side, you do to the other. It's like a balance. You can't disrupt the balance by only doing one thing to the other side. And it's all about finding the unknown. So now we're going to move on to variables and equations. Variables are letters that we substitute for numbers. Like I said before, we don't use E or I because they mainly represent something else that's really important. We don't want to get them confused. So the main thing we need to know is the difference between an equation and an expression. You see here we have the equation 4x minus 7 equals 5. The expression part is without the, how do I number this? Without the equal sign. Expressions have no equal sign, while equations have the equal sign. So when we're writing equations, we want to make note of our common words that indicate an operator, such as added to, divided by, each, stuff like that. So, and then there's consecutive integers, and there's a specific way you solve problems, like if you were given the sum of 5 consecutive integers is 155, what is the smallest? We'll get to how we do that in a bit. And then we have these 3 formulas which are really important. D equals distance equals rate times time, mainly for speed, distance, time. Work equals rate times time times manpower, and harmonic mean, which is, I know that looks like a negative, but that's just a dash, like up here. 2ab over a plus b. That is to find the average of 2 different speeds. So let's start with the parts of an equation. So let's start with the minus sign. That went to the wrong place. The minus sign is the operator. And our pink terms here, these are our constants. These are the numbers that do not have a variable next to it. So we all know that this is going to be the variable. And this 4 right here is going to be the coefficient. I think that's how you spell it. So now, that's our equal sign. And the last thing we need to know is 4x, they're together, they're multiplied together, so they're like bonded. 7 and 5, these are all called terms. This plays an important part when you're getting to factoring and polynomials, or binomials, or monomials. I don't really know how to say that. But that's why we have terms. They're really important. Remember, 4x is together one term, 7 is one term, 5 is another term. Okay? So now let's move on to our example problems. So we're going to do these 3 examples, and let's start with the first one. So we have, I'm going to button down here, we have the equation two x plus 5 is equal to 3x minus 2. So if you already know how to solve equations, I want you to try doing this on your own before I finish it. So the way we're going to start is we want to bring, so an equation is like a balance. What we do to one side must be done to the other. You can't just do something to one side. If you do the exact same thing to both sides, in the end, it's equal. So, what we want to do is we're going to move the x's to one side, and the constants here, we all want them on that side. That way, we can isolate the x. Isolating the x is really important when solving equations. So, what we're going to do is we have to think, what will cancel out this positive 2x? What plus 2x or minus 2x will equal 0? So we're like, maybe the opposite. So we're going to do minus 2x. 2x minus 2x is 0. So since we did it to this side, we have to do it to this side, or else it's not equal. So doing that, these cancel out. We'll get 5 equals x minus 2. So now what we're going to do is you can either think to yourself, what minus 2 is 5, and you'll be like 7. But for more harder ones, what you'll do is you're going to isolate the x even more. We do not want this minus 2. We absolutely hate it. We despise it. We want to kill it. So like we did in minus 2, the only thing that will make it 0 is plus 2. Since we did it to this side, we have to do it to this side. That way the 2's cancel out, and we're left with x equals 7. Now, if we want to make sure that this is correct, we're going to want to substitute that back in. So we're going to do 2 times 7 plus 5 is equal to 3 times 7 minus 2. 14 plus 5 is 21. Or no, 14 plus 5 is not 21. I don't know how to add. 14 plus 5 is 19. 21 minus 2 is 19. So that's how we do the first example. And since 19 equals 19, you know that's our correct answer. If you have any questions, you can comment below and we'll probably reply back. So now we're going to do the second one. This is when our writing an equation skill comes handy. So the question is, John gets $5 every week. Currently he has $13. He needs $47 for a game. How long will it take? Well, how long will it take for him to have enough money to get that game? So what we're going to do is, actually I'm going to change this to 48. The problem will make more sense then. So it's $48 and gets $5 every week, starts with 13. So let's set a variable for the number of weeks. And since weeks starts with a W, let's use W. So an important thing so we never forget is it's easy to say let W equal the number of weeks. That way we know what W is. Or we can just say W equals weeks. Okay? So he starts with 13. So we're just going to be like 13 plus. And he gets $5 every week. 5W. 5 every week. This is how much he... So after after W weeks, he's going to have a certain amount of money. And that amount of money is 5W. Once again, 5W is the amount of money he has after W weeks. And since he starts with 13, we're going to have the 13 here. And then we want 48, sorry. So we get this equation, 13 plus $5 every week equals $48. So we want to isolate this term. So we're going to subtract 13 from each side because that way it will become 0. 13 get, that cancels out, we'll get 5 weeks for, not 5 weeks, $5 every week for gives you 30, he needs $35. So he needs, after we have the $13 that he starts off with, he needs $35 more dollars. And since he earns $5 every week, we need to see how many weeks will need to happen for him to get $35. For this, you can think 7, which is easy, but if we were to use it, we see here that this is technically 5 times W. So we want to cancel out this 5. So we're going to use division. We're going to divide each side by 5. Something helpful is whenever there's a whenever it's plus, you're going to use minus. Whenever it's minus, you're going to use plus. Whenever it's multiplication, you're going to use division, like in this case. Whenever it's division, you're going to use multiplication. We'll get to what happens if there's an exponent later. So when we divide, we get the 5's cancel out, W equals 7 weeks. You can try it for yourself, but if we were to try it, we'd do 7 times $5 every week equals $35. $35 plus $13 to start off with gives us 48. So that's how we're going to do the second one. Now, the third one. Doing consecutive integers is confusing at first, but you'll love it as time goes on. So if we start off with x, let's just say x is going to be our smallest. We're going to say, let's write x equals smallest. So the first one is going to be x. The second one is going to be x plus 1. The reason is, if 5, 6, 7, 5 plus 1 is 6, 5 plus 2 is 7. And we're going to do x plus 2. Moving on to x plus 3. And then x plus 4 equals 155. So if x would be 5, I'm not saying it is, it probably isn't, then we'd have 5, 6, 7, 8, 9. And these are all consecutive. If you don't know what consecutive means, it means one after, the one right after it. So we're going to combine line terms, combining all the x's. There's 1, 2, 3, 4, 5. We get 5x. Now we need to add up all the constants. 1, 2, 3, 4. The way we're going to do this, 1 plus 4 is 5, 2 plus 3 is 5, 5 plus 5 is 10. And this is equal to 155. And now what we're going to do is we're going to solve for x. So first, subtracting 10, we get 5x equals 145. Dividing by 5, x is equal to 29. So you can always try it out by doing 29 plus 30 plus 31 plus 32 plus 33. And when you do the math, you get 155. And that's how you check that one. So these are all the examples for solving for x, writing expressions, consecutive integers. So now we're going to do these 3 example problems. The first one is, how long will it take to go 10 miles at 5 miles per hour? So we're given the distance and the rate or speed. So we're probably going to be using the formula d equals rate times time. In this question, they're asking how long. So they're probably asking for the time. So plugging it into formula d equals rt, we need to know what to plug in first. So our distance that they've given us is 10 miles. And the rate or speed they've given us is 5 miles per hour. Plugging this in, we get 10 equals 5 times t. So we want to find what t is. To do that, we're going to divide both sides by 5, which this becomes 2, this becomes 1, so t equals 2. And since this is miles per hour, our answer is going to be in hours, so 2 hours is our answer. And you can think, if I go 5 miles per hour, 10 miles is going to take 2 hours, so you can check it like that. So now we're going to move on to the 5th example problem. It says, if 10 people can dig 3 holes in 1 hour, how long will it take 5 people to dig 6 holes? Let's see which formula we're going to be using first. We're not going to be using this, we don't have any speed. We're not going to be using this because, like again, we're not trying to find the average of 2 speeds. So we're going to be using W equals RTM. So W stands for work, R stands for rate, T is for time, and M is for manpower. It just means how many people are doing it. So in this problem, we have 2 scenarios. We have a M, which is going to be 10 people. We have 3 holes, which is going to be our W. And we have 1 hour, which is going to be our time. So we want to find the rate for this first. That way we can find the rate and plug it in here to find the time. So doing so, we get 3 equals R times 1 times 10. Solving for R, we get 3 tenths. So now we have to find the number of time for the second scenario, which when we're given the manpower is equal to 5 people. We're given the work is 6 holes. The time we're trying to find, and the rate we already found right here. So plugging this in once again, we get 6 is equal to 3 tenths times time times 5 people. Simplifying, let's cancel out this to get 6 is equal to 3 halves t. So this gives us t is equal to 6 times 2/3, since we're going to multiply by the reciprocal, which is equal to 4 hours. Right there. So that's how we're going to do number 5. Now we're going to move on to the 6th one. And the question is, if Bobetta goes at a speed of 2 miles per hour uphill and 10 miles per hour downhill, what is her average speed? The last thing that says average speed gives away that we're going to be using harmonic mean. So, that's not a negative, that's just a dash like this one. So 2AB over A plus B is the formula. A is one speed while B is the other. So I'm just going to write that. So let's say that A is going to be, let's have A equal 2 and B equal 10. Plugging it in, we get 2 times 2 times 10 over 2 plus 10, which simplifies. 2 times 2 times 10 is going to be 40 over 12, and this is equal to 3 36 and 1/3. So that's going to be her average. So that's it. So now we're going to go over linear equations. The things we're going to cover in linear equations are slope-intercept form, slope, point-slope form, standard form, parallel and perpendicular lines, and horizontal and vertical lines. So you can see that I have a beautiful graph here, and it intersects 2 points here. The one that is intersecting the x-axis is called the x-intercept. I'm not going to write the whole word. And then the one that's intersecting the y-axis, is the y-intercept. So these points are, well, you always write points in x, y, and the x is going to be 0, and the y is going to be -2. In this, the x is going to be -3, and the y is going to be 0. So what we know from here is we have an x and y intercept and a line going through them. We want to find the equation of the line, and let's start with it in slope-intercept form. Slope-intercept is, I'm just going to write this in black, y equals mx plus b. In this case, b is going to be the y-intercept, x is going to stay as it is, so is y, and m is going to be the slope. So how do we find the slope? Slope is more important than anything else. The formula is y2 minus y1 over x2 minus x1, otherwise known as rise over run. And so let's first figure out the slope of this line using the rise over run thing. So we draw a little growth triangle here, and you see it goes up 2, and it goes to the left 1, -1, -2, -3. So if it goes up 2 and goes to the right 3, then our slope is going to be 2 over -3, which will also equal to -2/3. The other way we would find it using this is by doing -2 minus 0 over 0 minus -3, which is equal to that. So now we have our slope. Now we want the y-intercept. The y-intercept is just this number here. We're going to ignore the 0, and we see that the line intercepts the y-axis at -2. So our thing b is going to be -2. Writing this in slope-intercept form, we get, I'm going to write it here, y equals, our slope is going to be -2/3, -2/3 x minus 2, or plus -2, which gives us -2. So now we're going to move on, let me get the eraser. We're going to move on to writing it in point slope form. So I'm going to erase all of this. So how we're going to write this is, we have our formula, y minus y1 equals m times x minus x1. So it says point slope, so the things we need for this is a point, doesn't matter which, it doesn't have to even be one of these two, but I'm going to use one of these two because it's already there, and we're going to need the slope. We already have our slope, -2/3. So the way we want to interpret this is y minus y1. This is going to be part of this, one of these points. This is just going to be y equals m our slope times x minus x1. So the way we would write it in point slope is just, let's pick, I like the number 2 better, so we're going to use this one. So we're going to write it as y minus, and then our y for this is going to be -2. So we're going to write this as -2, substituting it for y1, equals slope, -2/3. -2/3 times x, we're going to write the first x as it is, minus, and when we notice our x value, or x coordinate for this, is going to be 0. So this simplifies to y plus 2 equals -2/3 x. Want to remember the negative signs. Signs are crucial in this. And if you notice, basically, if we move the 2 to this side, we get the same thing as this. So we can see that these two are equal. So let's write that down. Write the slope to 2/3. And our point slope form ends up as y plus 2 is equal to -2/3 x. And that's point slope. Now we're going to move on to standard. So I'm going to erase all this. In case I didn't say it before, we're using this line for slope, intercept, slope, point slope, and standard form. And parallel and perpendicular lines. So now we're going to move on to, like I said, we're moving on to standard form. So the standard form is ax plus by is equal to c. And this a, b, and c are all constants. And x and y just stay as they, just are x and y. So we're going to choose one of these. It really doesn't matter which. I'm going to choose this. And we're going to manipulate it in a way so we get this. So writing it down, we got y equals -2/3 x minus 2. So one thing about this is there are no fractions. So I'm just gonna write that here. No fractions or decimals. Okay. So since we have a fraction right here, we're like, because we can't have any fractions, we're gonna multiply this entire thing by 3. Doing so, we multiply 3 by y to get 3y. 3 times -2/3 x is going to give us -2x, and then 3 times -2 is -6. So once we do this, we want the a to be positive. Like I said here, a always should be positive. So we're going to move it to this side. To do this, we add 2x to both sides to get 2x plus 3y is equal to -6. And that's it. So that's standard form. And let's write that down. 2x plus 3y is equal to -6. And now we're going to move on to parallel and perpendicular lines. So erase all this. So take a moment, imagine how a parallel line, a line parallel to this green line would be. Would it have the same slope, same x-intercept, same y-intercept? How would you describe it? So take a moment to do that. So the way you would do that, so the way a parallel line is it has the same slope but different y-intercept. So let's say a rough sketch of something like that. Let's just pretend that it's parallel. It doesn't look parallel, but let's just pretend it is. It's gonna have the same slope as this one, -2/3. Because if they have a different slope, they're gonna be at intersect. But since they have the same slope, they're not going to intersect at all. And they just have a different x-intercept. So with the x-intercept, with this one's x-intercept, the red one, its x-intercept is going to be 0, its y-intercept is going to be 0, -1. Let's write the line, the equation of this line in slope-intercept form that is parallel to this green one. So the way we do that is basically, we know the slope already. It's going to be -2/3. The only thing we don't know is the x-intercept. But we're given that the x-intercept is 0, -1. So this is going to be the line parallel to this green line. If we were to have it go through like this, we're going to have to use a lot of imagination here. Then our line would be y is equal to -2/3 because it intersects at 0, 0, which is the origin. So that's how we would do parallel lines. Now for perpendicular lines. Basically, if we were to have a perpendicular, so now we're moving on to perpendicular lines. So I redrew the graph, and this was our line from before. This right here. I'm going to label this line line 1. And this one shall be line 2. So these aren't, I try to draw them as straight as I could, but they are perpendicular. And the way so if we were to given that this point, there is a perpendicular line that travels through, it's going to be 0, if there was a perpendicular line that travels through 2, 0, and it's perpendicular to y equals -2x minus 2, 2/3 x minus 2, then what is the equation of the line? So basically in this, it'd be easier if we had the y-intercept. So the way we'd figure this out was, whenever there's a perpendicular line, well, two lines that are perpendicular, their slopes are negative reciprocals. For example, if the slope in this is -2/3, the slope for this is going to be 3/2, positive. We flipped it over and changed the sign to get 3/2. That's going to be our slope. And the way we find the x-intercept is, well, we wouldn't even have to find the x-intercept if we were to put this in with 2, 0 and the slope into point slope and then changed it to slope-intercept form. That is by far the easiest way to go about it, the most useful thing that point slope form does. So putting it in, we get y minus, our y1 is going to be 0, is equal to our slope 3/2 times x minus our thing's going to be 2, and simplifying, we get y equals 3/2 x, and then the 2 will cancel out, -3. And if you can see right here, our x-intercept is about -3, which is shown right here. So that's how we're going to find perpendicular line. The slope is going to be the negative reciprocal. Hold on. So these are our answers for the parallel and perpendicular lines to this. So now we're going to move on to the horizontal and vertical lines. They're just as the name says, horizontal and vertical. But the only thing you need to know about them is if you were to have a horizontal line, not use purple, if you were to have a horizontal line. This line would be y equals 4. And that's it. It'd be y equals a number, and that's going to be horizontal. And for the vertical ones, this is going to be x is equal to 2. X equals a number is going to be vertical, while y equals a number is going to be horizontal. That's basically all you need to know about vertical and horizontal lines. So now we're moving on to our final topic, systems of equations. Systems of equations are when we have two equations or two or more equations with two or more variables. So for now, we're only going to learn how to solve for two variables if we're given two equations. So I have 3 examples for us today, and I'm going to teach you as I show you how. So this is number 2 is going to be the easiest. So we're going to do this a bit out of order. We'll start with number 2. So we're given the two equations, x minus y equals -6. And the equation y plus 8 x plus y equals 8. So something amazing about these equations is we can add them, subtract them, manipulate them any way we want. So for this one, we want to solve for one variable first. And the best way to do that is through elimination. To do elimination, we must eliminate one of these variables. And the way we would do that is, if we need to, we can multiply, add, subtract, well, mainly multiplying or dividing a certain number by any one of these equations, and then adding or subtracting the two. So for this, let's look at it a bit closely, and we have negative y and positive y here, and x and positive x. So we think to ourselves, if I just add these two, I can easily cancel out the y's. So if we were to add this, what we do is x plus x is 2x. Negative y plus y is going to be 0. And then negative 6 plus 8 is 2. So we get the equation 2x equals 2. And when we solve for x, we get x equals 1. And now we plug it back in. We can plug it into either one of these, and it really doesn't matter. So we're going to plug it into this one, and we get 1 plus y equals 8. And then we easily know y is equal to 7. The reason we can add these is that technically, if x plus y equals 8, this is a bit confusing as of why we can do it, but if x plus y equals 8, then technically x plus y is equal to 8. So we're adding x plus y to this side and 8 to this side. And since they're perfectly equal, we won't be changing a thing about this equation. Because like before we said, is if you do one thing to one side of the equation, you have to do it to the other. So we get our answer, 1, 7. You always write it like this, x, y. And to check this, we have to plug it back into both equations. It won't help if it only goes into one equation. So if we get 1 plus 7, 1 minus 7 is negative 6. 1 plus 7 is 8. So we're good. So that's it for the second example. So I am going to put that here. And now let's move on to the first one. So this one's a bit harder. We have 5x plus 8y is equal to negative 51. And then 2x plus 3y is equal to negative 20. There are a bunch of big numbers in here, so that's going to be really annoying. So we want to cancel out x or y first. And the way we do that is, since we can't cancel out anything directly like we did for this, we're going to multiply each of them by a certain number so they cancel out. And since 5 and 2 are smaller, we're going to cancel out the x first. So we want to think of a term that we can multiply this equation by, so that we get a number that when we multiply this equation, we get like the same thing. So we have this problem and we want to eliminate the x. The reason we're choosing to eliminate x is it's going to be probably much smaller than it is to eliminate y. So we want to think of a common term that we can reach for both that can work. So if we think about it, we think and find the least common multiple of 5 and 2, which is 10. So we want both of them to have 10x. So I'm just going to write that here already for both of them. So for this one, if we want 10x, we have to multiply this entire thing by 2. So we get 10x plus 16y is equal to negative 102. And for 10x, for this one, we multiply the entire thing by 5. 5 times 2x is 10x. 5 times 3y is 15y. And then negative 20 times 5 is negative 100. So since we have 10x and 10x, we think to ourselves, I can't just add them. So I'm going to subtract them. So basically, you're putting a minus in front of it and distributing it to each one. So 10x minus 10x is going to be 0. 16y minus 15y is y. So you always want to remember, you have to distribute the negative. And then negative 102 minus 100 is going to give you negative 2, because it's technically negative 102 plus 100. So we get y is equal to negative 2. Let's plug it back into this second one because it has much smaller ones. 2x plus negative 6 is equal to negative 20. 2x is equal to negative 14. X is equal to negative 7. Plugging it back in, it will work. So we get our answer negative 7 comma negative 2. So let's write that down. Pocket won't work. So this last one, if we have the that is for you guys to do, but I'm going to help you a tiny bit with that. We have the sum of two numbers is 10, difference is 6. So let's just think of it this way. Your two numbers are going to be x and y. X plus y is 10, x minus y is 6. And there you have it, and that's it for today. Don't forget to subscribe and like. If you have any questions, you can email info@agoramatrico.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!